On this episode of Built to Last, we go on site for the latest in framing techniques. We'll also drop in on a job site to see how quickly a state-of-the-art wall panel system can take shape. Finally, we head to the Carpenters Training Center for a demonstration of welding skills by apprentice carpenters. Next on Built to Last. Hi, I'm Bruce Obora. Our goal this season is to show you how the latest construction techniques are used in building better residential and commercial structures from the bottom up. Whether a project calls for wood or steel beams, framing, the bones of a building is what makes the structure as important as the foundation it's built upon. Let's find out why.
Wood framing, metal framing, and prefabricated walls are all state-of-the-art methods to assemble a structure on a foundation. Chet Bussey, a senior project manager for Pepper Construction, has seen framing materials and methods improve.
As your time and experience being a carpenter and a superintendent, how have you seen things progress as far as construction?
Well, over the years, early on, there was a lot of wood framing, mostly all wood framing. Metal framing became more prevalent. It seems to be a faster, easier method.
Is there any other trends you see as far as material usage that is becoming more prevalent?
We do see a lot of manufactured wood products, LVLs, beams, plates. They're stronger. They can be manufactured in lengths that you can't get common lumber in, and they're readily available.
Already in progress, Pepper Construction was contracted to build a new commercial space and the renovation of Barrington's historical White House.
Well, we have a community center we're building here. It's an old residential building, built in 1898 originally, and we are rehabbing it historically 100%.
100% means that every inch of this house is about to get restored under the direction of a master carpenter.
One of the most important sustainable strategies that Pepper Construction Company has employed here at Barrington's White House is reusing and restoring existing millwork. That is helping us, instead of harvesting new trees and making products out of new wood, we're able to use the existing wood and put it back into place, not only to maintain the historical character of the building, but again, to conserve resources. And in order to be able to do that, you have to have a master carpenter that knows how to reuse the wood properly.
Master carpenter Tony Frazone was in charge of the wood restoration for Pepper Construction. A union carpenter with more than 30 years on the job, his experience was put to the test.
This column here, fellas, is totally rotted on the bottom. This is a solid piece of wood. Wow. This is solid poplar. This column was rotted on the bottom. So what I've done with this column is I've cut a V in it and got all the rotting out. I'm going to re-glue it and join it into here with cedar. And then we're going to continue these flutes through and patch it. The other column is another one where it is glued together, and the glue it fell apart. So this one's all in pieces. So as you can see, it creates a circle as you go around. So as you can see, you create the column as it's put together, kind of almost like a whiskey barrel. But that's that column, but it was a different era This is a hollow column inside. That's a solid piece of lumber. Here's a piece of base that's damaged. I mean, there's no way we're going to be able to reuse this. It's totally damaged. So what I've done is I've taken it. I mean, in an example, for these panels that we're making, that I showed you to repair inside the wainscoting, this width here. So there's various widths. I've taken them down and I've cut them for a length rough, and then I've run them on a saw and cut 2 pieces out of this board. So actually, when I cut them 2 pieces out, I flip them and I glue them together, which you can see right here, which is the book match. You can see it right here. This is actually the joint right here. This is in its rough stage of sanding, and then it's a 1/4 inch to 3/16 wide, and then there'll be a piece of plywood glued on this to keep it stable, and we've got our panel back. This is another example. So we needed a stile or a rail that was about 2 inches wide. So right now, I mean, out of this board, I've got like 4 pieces. And then after that, we glue it and laminate it right to a piece of plywood, which keeps it very stable, and you've got yourself a nice board, very stable board, and everything it works out real well. And as you can see, out of a board like this, you yield like 3, 4, maybe 5 panels in some of these. So actually, you're really working out good, because this kind of material, this is for first growth trees. And this quartering in here and quilting in here and the patina of the wood still deepens in color, even though when you cut these in half, you still get that richness in the color. So these are things you're not going to be able to find.
So Tony's told you a little bit about how we're reusing wood and saving trees in the process, and doing a historic renovation to this beautiful building. A few other strategies that the Carpenters are involved with is, you probably saw before as you walked around, there's a lot of framing here. And in the past, traditionally, there's been a lot of wood that's been scrapped, sent to landfills, and now there's processes where we can shred it and reuse it. But even so, the best thing is eliminating the waste. So it's important for carpenters to go and engineer their framing programs to minimize the amount of wood waste on a project as one important sustainable strategy.
A project as sophisticated as the restoration of a home built in 1898 is the domain of a skilled tradesman.
Carpentry and carpenters are very critical to the sustainable construction process. Here at the Barrington White House, and where I am right now, you can see some of the strategies employed. One is, we're very concerned about interior air quality, both during construction and how it affects the occupants afterwards. So we're trying to minimize dust. And as you can see, with a lot of wood and sawing going on, that can get released into the air and create health problems for not only the current workers, but future participants in the project. So we have things right here. The carpentry tools have become sophisticated, where we have vacuum attachments like the one you see here, or if you go over here into the master carpenter's workspace a little bit more, you'll see there's vacuums and attachments on table saws, and you'll notice in this space there's very little dust, if any. You really have a clean air, sort of like you're in somebody's living room. So that's one of the strategies, and carpenters are critical to knowing the right equipment to use for the right task.
Months of work in the exterior and interior of the Barrington White House should prove to be a benefit to the village and a great example of sustainable building practices.
We are a few months later now, and we've gone through all the engineering process and approval process for that. The light gauge trusses have been approved. You can see they're in place. We've started to place them. They're about 90% complete. We just have this north elevation to finish off. The structural steel trusses, there are 6 steel trusses included in this frame. They're in place with the light gauge system tied into that, along with all the structural reinforcement all the way down to the basement foundation is in place.
The 3rd floor of the historical residence present new challenges. Its new life as a social center for public use required special attention for the roof of the ballroom.
As you can see, we have light gauge metal framing and a truss system here. Some structural steel trusses that go along with that light gauge framing.
Okay. And then as far as wood framing, is kind of traditional stick-on-site framing?
Yeah, I think we do You may do some prefabrication on wood framing. These knee walls here on this floor were fabricated on the ground in large sections and in place, but typically I think wood framing would be more stick-built, especially on an application like this. You get maybe a straighter, better product out of metal construction, especially in new construction areas. Carpenters are used to using those materials now, and they are good at installing them quickly.
On the third floor of the Barrington White House, an engineered steel truss roof mimics the original wood roof. It's the marriage of 1898 style with 21st century design, perfect for a residential home repurposed to be a community center.
The original roof, wood-framed roof, was scanned before we started the project. That information was given to the architects and engineers, and they duplicated the design. This addition in the back is a larger addition than was here, so this framing is a little bit different. But with the new metal framing that we have here, we were able to achieve the headroom that we see. This will be a ballroom, banquet hall on this floor. We'll have 18 to 20 foot of headroom in some spaces. The metal framing actually helped allow that to happen.
This is the commercial portion of the project in the village of Barrington.
Chet, we're here at this is the commercial retail portion of the job site here, and this seems to be a great example of some commercial framing going on.
This area gives you a little snapshot of a lot of things going on. We've got our foundations in place, obviously, steel framing in place.
On site at the new commercial structure, framing work is underway. Framed with 18-gauge cold-form steel studs, the structure will house 6 retail stores.
So the guys on the job site, they're all union carpenters, and they have had extensive training in framing a building like this. Clark Dietrich is the designer and engineer of this framing system, so they have to follow their strict guidelines in what they do and how they install it.
With the frame secured, work on the building envelope has also begun to take shape.
You can see the Duns glass sheathing and the foam board insulation. It's R7.5, along with our vapor barrier on top of that.
And then I see you kind of turn it down on any openings and penetrations.
All the vapor barrier gets wrapped and taped. All the seams are taped. There's a recommendation on the spacing of the fasteners, along with the brick fasteners and ties in conjunction with that also.
Now with this, everything's continuous. The sheathing runs continuously through uninterrupted, obviously, except for openings. Then you run the insulation through. Everything becomes a continuous, basically, membrane on the exterior.
Well, these parts here, these components, are the envelope of the building, really.
Now I see here you've got quite a bit of the roof framing in place.
This right now is light gauge metal roof trusses again, in components. You can see the top section comes separate. We attach it to the bottom sections. Start with one piece, brace it off very well, and then continue with the rest of them, bracing as we go. These are like false roof members on top of the roof. They will get closed in, sheeted, vapor barrier, and this product behind you is what you see is how it's going to end up. It's going to have asphalt shingles on it, a Duns deck siding with a roof membrane that actually runs up to that bottom of that and flashed in.
So this is really, it's a great use of material. By going with steel, it's less material than wood. You're 24 on center. It's a pretty lightweight system.
It's lightweight, it's installed very quickly. We can hoist these trusses up here in a bundle and spread them out, and a couple of carpenters can frame this area in a day.
Back at the Barrington White House, several months of work on the renovation have yielded great results combining a steel truss system.
structural steel trusses. There are 6 steel trusses included in this frame. They're in place with the light gauge system tied into that, along with all the structural reinforcement all the way down to the basement foundation is in place. This is a very complex truss system, even for a residential structure, let's say. The engineering and approval process that went along with that was very time consuming, very tedious. It took a little longer than we expected. We were able to complete other work inside the house to get to this point, and when the trusses did arrive on site, we were able to kind of expedite that installation. The system itself is engineered as a complete system. You can see there's a lot of temporary bracing in place to hold the structural steel trusses in place, and then temporary and permanent bracing to hold the light gauge trusses in place also. It's a light gauge, 18 gauge steel frame truss system, all engineered connections on the plates. The temporary bracing system was actually engineered also. That took some time. And that'll be in place until the roof is sheeted and completed.
While structural steel is a new component to this home, it is a sustainable renovation as many of the original components were reused.
This is a historical renovation, a reuse of a lot of materials that were taken out and reused because of that, especially on the exterior siding and trim. The entire north elevation and most of the east elevation has been reused, all the original components.
Over the next few months, the Barrington White House will be returned to its original glory, celebrating the village's 150th anniversary.
The village is trying to be at the forefront of good design and good building codes. And when this project happened, everything that we were doing on it, we were trying to make it as sustainable and environmentally friendly as possible. But as we got further into the project and realized that there were other steps that we could take to make it even more sustainable, part of that was because we had people working on the project who had a lot of experience with environmentally sensitive buildings and different ways to create as sustainable building as possible. And when Pepper Construction came to us and said, you actually are already at Silver LEED without doing anything different than what you've already been doing as part of your building process, and you may want to really consider trying to attain Gold LEED.
During the process, we did do a lot of investigative work up front. We cut holes in the walls and we looked around and saw what we could see. As we did some of the major gutting of the interior plaster and drywall systems, we found that there were no headers above the windows, and that's how the balloon framing may have been done at that time. The windows themselves are very substantial. Maybe they were part of the process of supporting that wall. As we went through this project, we found that the age of the wood, the oak floors and the oak paneling and trim pieces, they're very old and they're very hard and very strong. You probably can't get material like that nowadays. It was certainly worthwhile stripping and refinishing. We found that we had to re-glue just about every panel and piece around here. The glue had failed over time. But you know, the final product tells us that it was well worth the effort on that.
Our goal in the village is to always be as sensitive to the environment as possible and do good practices. This will be the first Gold LEED building in Barrington and also the first geothermal building. So it gives us a chance as a village to say that this is an important thing for all of our residents. And we're hoping that it will create the least impact on this site for the future as possible, and that it's just a good way to do a construction project.
It's a steel thermal efficient panel made up of 2 time-tested materials. There's metal stud framing and expanded polystyrene insulation. The unique thing about the panel is the way that the 2 materials are bonded together. The foam is fused through the metal stud, which eliminates the bulk of the thermal bridging
that occurs in metal framing. All the panels are, they're 4 foot wide. The studs are 2 foot on center. Those are fixed dimensions, but we can make them any length that you can ship them. We actually stock 36 foot and 24 foot long panels, and then we cut them down to size for the specific project. We engineer it in-house. Everything is cut to length, jambs, headers, all the trimmings for the windows, the panels themselves are all cut and tagged specific to your job. Start off by laying your base track just like you would any metal frame wall. Then you would go to the drawing, see what panel is the first panel in a run of wall. The layout's on there for you where it's supposed to be set. And then it's just a matter of standing them up, putting the tongue and groove together. It's a dry fit, and screwing it off to the track. The one unique thing about the wall panel is it still has a 3 5/8 open cavity on the inside of the structure to still run your electrical, all your plumbing, all your MEP items through. We put our jam studs and headers in that cavity so that it stays behind the insulation and maintains the thermal performance of the wall system. Taking advantage of our ability to make long panels that could span past 2 or 3 floors of a building at a time, and without the use of cranes. Because the panels are light, it doesn't take a lot of extra manpower for handling and stabilizing. 2 guys can carry a 36-foot panel, flip it up against the side of a building with, walking it up, and somebody with a rope pulling it. And if there is like a second floor, they'll just come back later and just walk through and screw the panels off to the clips on the second floor.
Carpentry trade, we don't always work with wood anymore. And so going forward into the future, carpenters got to be able to work with and deal with many different materials and applications of those materials. And welding sets you up to really be able to do a lot of different things.
Try to keep that in the green.
Virtual welder is great. It allows you to really get the feel of it down and get the process down. And then when you go out in the shop, you're just basically doing the same thing. And you haven't, it's like you've done it before, but you haven't. It's kind of, if that makes any sense.
They actually show you the pace, accuracy, and all that good stuff. So by the time you get down into the workshop, you already got a little hands-on.
When you put on a hood, it's virtual reality, and you can just keep hitting the same piece of metal until you get it just right. And you're not wasting material, not wasting time. It makes it a little bit easier because the instructor can be standing right there. You can see exactly what you're welding. You can actually see what you're seeing on the virtual reality on the monitor. And he can prompt you and kind of give you pointers.
In their goggles there, they have little actions and cues. So you can see where if they're holding their rod at the wrong angle, if they're traveling too fast, if their arc gap is too long or too short. We see here on the screen is what he sees in his goggles right now.
You're on the machine, you're learning your speed, the proper arc distance, the distance from your welding rod to the actual metal, getting the right penetration, not too far, not too close, not too fast, traveling in a straight line, getting a nice clean weld. Repeat the process again and again until you get it just right. Then when you go down in the shop, you're just repeating that process. You're just doing that same thing again.
If I use this first and I go down there to the workshop and then really weld, yes, I believe my time and speed would be a lot better.
Probably the most important thing would be just making sure you've got the proper penetration on the weld and making sure that you've got a clean weld. You don't want any slag or contaminants inside the weld. Any crack or any deviation is going to weaken it. You can't have that, especially in a structural application.
More and more contractors are requiring it. Now they want people certified. They got to have the job go right. They want someone that's experienced, know what they're doing. Carpenters, they use it a lot on metal studs, commercial buildings. They're made out of, galvanized metal studs. They got to be certified to weld on the bridges also. Millwrights, we do all our welding on machinery and the structural steel that holds our machinery up.
With precast panels, Once you tilt that panel up, you're going to have a big steel plate, and you need to tie those panels together. That's structural weld, so those welds got to be done correctly, and they got to be done by somebody that's trained and knows what they're doing.
If you don't have all the variables right, which is the correct speed, the arc gap, and angle, you're not going to have a good weld, and that weld could fail.
Whether your construction challenge is commercial or residential structures, we hope that our guests today have helped you build a good foundation for best practices in the construction trades. I'm Bruce Obora. Thank you for watching Built to Last.
Visit the Built to Last website to learn about these topics and more.